name is Michele Vavallo. I'm the project coordinator, and I'm going to talk about the concept and the methodology of the project. I work in Solintel, Spain. Yeah, let me see, because I'm clicking. Yeah, so you can see here some figures of the summary figures of the project. The project started in October 2017, and it will finish in September 2021. It is a project that belongs to the energy efficiency building in Horizon 2020 call from 2017. You can see we are 90 partners spread out all over Europe. You can have a look at the logos of the company on the right side of the slide. And other figures are that, as you know, we have two real demonstrator building. The first one is in Estonia, and you will be introduced to it. It is a private residential building, and the other one is in Durango, in the north of Spain, in which that is a public residential building. Afterward, we have also three virtual demonstrators. We have a big shopping mall in north of Italy, and building office in Greece, and another residential building in Bulgaria, in Sofia. So what we would like to achieve with the project, mainly 16% cost reduction of renovation, 60% energy consumption in reduction, and 65% renovation process time reduction. You can see the map of the demos of bottom right of the slide. Now, why the project? The state of the art we had in 2017 was that the renovation trend of the residential building in Europe was and is very low. We are talking about 1.2% of building stock replaced annually, and according to the 2050 European targets, we have to achieve more than the double of this percentage. It is 2.9%. Why there is this gap? The gap is because this kind of works are expensive, are complex, are disturbing for the occupants, are sometimes inefficient. There are problems related to the harvesting, gathering data, and sharing. In the duplicate efforts, some very a lot of times in the sector. So for this reason, we have this gap, and also for this reason, we created this project. It is one of the projects that have been, well, we have worked into this barrier, trying to tackle it, creating a plug and play system, modular system that will be introduced by Focchi, a well-designed renovation methodology in a cloud collaborative environment. That is all the software part, the tools, and also the collaborative platform that involves all the key stakeholders all over the process of retrofitting, and considering the property value as the main trigger for the renovation, because sometimes you have a solution, a lot of solutions, you would like to use all the solution in the building, but you don't consider the financial investment. You don't consider how the building is actually being improved in terms of property value. And so this project has created also a KPI related to this issue as well. Very interested. So main objective, as I told, is to unlock the renovation market in Europe, mainly of this kind of building from 60 to 80 years, and it is the biggest stock of building we have in Europe that has to be revamped somehow, because we have a lot of energy losses there. So we could gain a lot of we could improve the building in the end. I mean, so to do that, we have worked into this innovative component that we are going to introduce to you: innovative processes, decision making methodology and mechanisms, and also to guide the value chain actor in the all over the process of the renovation, from design, plan, manufacturing, and also getting to the maintenance, the last part. So again, the four pillars of the project is just to sum up, is reducing energy consumption and increasing the renewable energy, cost and risk reduction, and decreasing the disruption from the occupants in the building, improve and boost the replicability and the adaptability through the modularity of the facade, and also the solution application. And again, we considering the property value of the building as a trigger. So increasing the value of the building is also one of the aspects in considering this in this project. And I think that I'm done. Thank you very much, and I leave the floor to Zafer. Thank you very much.
Good morning, everyone. My name is Zafer Ozturk, and I will have a short video first for you guys. And then after watching the video, I'll be back to answer your questions. Enjoy the video.
Dear stakeholders, welcome to the RenoZEB training on Knowledge-Based Engine, or KBE in short. I am Dr. Zafer Ozturk from ThinkLab, Salford University, and on behalf of my team, I will be presenting the KBE tool today. Knowledge-Based Engine, or known as KBE, has been developed to assist decision-making process during the initial planning phase of deep renovation process of RenoZEB project. A knowledge base is a centralized repository where information is stored, organized, and then shared. In this respect, RenoZEB KBE tool is a service that it stores EU-wide climate data and building level energy performance data from multiple sources. Also, it processes and refines the above mentioned data geospatially, and it generates and shares knowledge regarding properties' location-specific energy requirements and a local comparison with other dwellings in the area, as well as rough estimation of property value increase in return of an energy upgrade. In other words, RenoZEB KBE tool focuses on knowledge retrieval from climate and EPC data to maintain a better understanding of the interaction between local environmental conditions and the property-specific energy performance at abstract level, and features a comparison with similar buildings in the area. Well, let me walk you through the interface and demonstrate some hands-on practice. This page on the screen is the KBE login page. And once you receive your personal user credentials, you will be able to log in the system here. I have input my user credentials, and I am now just clicking on the login button, the yellow icon here. Well, this is our user interface for the KBE tool. On the left hand side you will see a menu that has the bullet points of dashboard, energy performance, climate data, and others. When we click on dashboard, it will take us to the exact screen that is being depicted. And when we want to skip to the energy performance, when we click on it, we see the analysis and view certificate functions. And the next one is the climate data function. When we click on it, we see that climate visualizer or cooling degree days and heating degree days function. And when we click on the other section, we come up with the area viewer function and also the download user manuals function. So let's go one by one with the dashboard. When we come back to the dashboard menu, there are four main functionalities, or let's say applications, on our dashboard. The first one is View Climate Data Dashboard. With this function, we can click on the application, and by using this app, we will be able to retrieve climate data across all European regions for given specific domains. The next function is the cooling degree days and heating degree days functionality of the KBE tool. And by using that, that will enable us to retrieve cooling degree days and heating degree days for a given specific location. The next application on the dashboard is View Energy Performance Certificate Data. And by using this, the app will enable us to retrieve Energy Performance Certificates, or EPC in short. We will be able to retrieve the EPC data with this application. The next one is similarly lets us to retrieve EPC data, but this time we need to provide the EPC values rather than selecting it from a specified location. We will come to that in a minute. And the last functionality is the Area Buildings 3D Viewer, which will enable us to depict the region of our building, and it will depict the 3D viewings of the buildings within that given specific area. So let's try these out one by one. As the attendees for today's training are mainly from Estonia, I would love to make few practical trials with Estonian data. Let's start with the View Climate Data function. We need to click on Select, the green button here. Once we click on it, it will take us to the function. So all we need to do is type the location in here. And then we need to click on Search. And then we would be able to select the period of data that we want to elaborate. It could be like 1 year of past data, like past 3 years' data, past 10 years' data, or we can select a custom period that we can select manually. But in my examples today, I will just go with predefined durations. Let's start with an Estonian example, city of Tallinn. I am searching for Tallinn now. And I am clicking on search. Then the system will ask me to select the exact city from the drop-down menu. I will click OK. And I am clicking to select the city of Tallinn. And when I click on View button, the system will bring to the screen the data request I made. I am clicking on the View now, the blue button on the left hand side. Yes, as you can see, the data has been displayed on the screen. It gives us the time period for the selected city or region, which is Tallinn in this case, and the data comprised past year's data because we have selected 1 year only. We can see here that average mean temperature for the selected period is 8.13 degrees Celsius, and average maximum temperature for the selected period for Tallinn is 11.44 degrees Celsius. Average minimum temperature is 4.84 and maximum temperature for the given period is 28.5 degrees Celsius. And similarly, the minimum temperature for the given period is minus 11.7 degrees Celsius. And another good functionality with this KBE tool is that we can send this report automatically to our email box. That will be the email that we have registered as our credential whilst entering the KBE tool system. I am clicking on now the green button which indicates the send report, and when I click on it, it automatically drops me an email. As you see, the report has been sent to your email account. You come up with a notification. And when I click on OK, it will come within a minute to my email box. As you see, it has already been sent to my mailbox, and it depicts that the name Climate Data Report from RenoZEB project. And the exact same report has been sent to my inbox here, as you see. And coming back to the system, I can now close the window. And in order to move on to the next functionality on dashboard, I am clicking on dashboard icon here on the left hand side. And now it is time to do a practice on cooling degree days and heating degree days functionality. Those are two very important parameters when making an initial selection on the deep retrofit in a specific dwelling. And heating degree days functionality. And when we need to click on select to enter the tool, and just like the previous function, we need to select the city name. And this time let's do an example from UK, from United Kingdom. And let's select my city where I am based. Let's type Manchester and do a search. And similarly, we can select the period for 1 year, 3 years, 10 years, and custom periods. But let's do a search. And it asks us to depict it from the drop-down menu, and it is Greater Manchester. And let's view the results. Yes, this screen depicts us the report generated by the climate data function regarding cooling degree days and heating degree days for Manchester for the selected time period. As you see, the total cooling degree days for the selected period is the 2 days only, and the heating degree days is 7,522. Those are the indications of cooling load requirements and heating load requirements for the selected period in the given location. And just similarly, if I click on send report icon, it will automatically send this data to my email box. Let's go back to dashboard and elaborate the other functionalities. Well, this time it is time to view the energy performance certificates. Let's get in this application by clicking on select. And this time we need to depict a country as well as the postcode. Okay. I will do that example for UK only, for my address where I live, because we have the full EPC, Energy Performance Certificate data set across Europe only for the UK, available to public. The Salford team is currently working on a database that will represent similar EPC values for all European countries, and the functionality will be available by September 2021, hopefully. And also you will be able to upload your own datasets. Let's assume you have a portfolio of buildings and you will be able to upload the data and other EPC related datasets to the system. Let's move on with the UK example. It is United Kingdom and my postcode here. And I click on search. Again, it asks me to select my address from the drop down, and yes, I found my address here from the drop down, and I click on it, and I click on view. As you can see, the system brought me the full energy performance certificate and all the related data. It depicts where the location is, the current energy rating, potential energy rating. The current rating is label C for my address, for my property, and the potential energy rating is label B. And it depicts the property type, which is a flat, and also it depicts the build form, which is a mid-terrace property. And construction age band is England and Wales between 2003 and 2006. It even depicts the tenure type, but also some other data related to location and all other specifications related to carbon emission rates, lighting costs, walls descriptions, window energy efficiencies, etc. All the data related to my property is available here. And similarly, if I click on send report, the system will email all this data to my mailbox. This functionality, as I said, is only available for UK data, but the Salford team is Of course, not comprising all the data like it is in UK, but it will be depicting similar indications of EPC for other European countries by this September. Let's move it to EPC Band B. Property will be among 285 number of dwellings, and property value will be increased by 4.8%. Again, this data represents the UK only. The country-specific data and indicators are being developed for all countries across Europe. And if I click on Send Report, this will automatically be sent to my mailbox as well. Coming back to the dashboard, similarly, with this function, the Energy Performance Analyzer, we can use it where we don't have any EPC registered with postcodes. In this case, we will be able to upgrade the database by providing our own data, and then we will be able to select the property types given for the exact area, and then we will be able to select the build forms like end terrace, mid terrace, enclosed mid terrace, semi-detached or detached, and so on. And then we can be able to input our own current EPC band, for example, let's say if it is C, and then we will be able to press on Get Report, and then it will make a comparison similarly to the one that is being made in the UK example. And it will compare our property with the neighboring buildings in that postcode, and it will give us an indication of a property value increase and among how many buildings our property will be is going to be indicated. Again, coming back to the dashboard to see our very final functionality is the area buildings 3D viewer. Again, we click on select. And this is just a basic functionality that depicts the buildings in 3D view format for the selected property, and it depicts all the neighboring buildings. In this case, the building has been depicted in purple. And we had elaborated all the functionalities of KBE in the dashboard. Similarly, let's check the final icon here, which is Area Viewer. It is the latest one, and when we click on the download user manuals, it is not readily available, but it will be there for sure for your usage by September. It will be depicting how you're going to upload your own data and the data format requirements. And this is the end of my recording. Thank you very much for joining us today.
So we have a few minutes for some questions to Zafer. Zafer, please. If anyone has any questions, you can raise your hand or chat or type in the chat box, please.
Yes, good morning, everyone. You can ask your questions by typing them in the chat if you like. The red ones were the public buildings. I saw the first question. It was about why the 3D in 3D view, why some buildings were red. Let me type my answer here as well.
Zafer, you can also say the answer, because then the translators can translate to Estonian.
Yes. In 3D view mode, the red buildings were the public buildings. It was just a functionality that our developer has put to depict that it is not residential building.
Zafer, apparently there is a question from Ivan. Can you pick up on that?
Yes, we are using the European databases for each of our data sources, and we can embed whatever data provided by the user as well, but we need to make sure that the data source is reliable first. But the data sources we used were let's say the climate data was taken from Copernicus database, and the EPC data is taken from the Energy Ministry of UK. And we are developing for other parts of the European Union, which are some local-based data sources, let's say from municipalities. And for the other ones, we are doing optimization modeling. And you can drop me an email if you like for further requests.
Okay, if we don't have any other questions, I guess we can move on. Alessandro? Yes, I gave you the control.
Thank you, Larissa. Good morning, all. I'm presenting you the Focchi facade system. So the facade solution, which enables the RenoZEB methodology and the renovation of buildings in deep retrofitting scenarios. Okay, just a brief outline about what I'm going to present you. First of all, the concept behind the RenoZEB envelope system. We move to the system design and then the detailed design of the RenoZEB envelope system for the demonstrators. In these overall scenarios, I'll focus in the first phase on the boundary conditions about the technologies, the building envelope limitation, and the idea behind this Focchi facade, focusing on a possible catalog that we can provide for this type of solution. Then I'm going to detail in the design of the facade with the final design and the building application. And I'll present you the test and the results achieved during the different activities conducted. And then some conclusion useful to recap some main achievements of the project. What are the boundary conditions for the realization of this type of facade? First of all, we set up different technologies to be included. We wanted to realize a building envelope capable to integrate in an effective and efficient way different technologies. All these technologies were part of a concept, an ideal concept for the deep retrofitting. So including insulation, sensors, piping, windows, ventilated solution for facade, and all those technologies that now are included in retrofitting scenario, but for deeper renovation solution. These technologies were included and integrated in a concept of facade. This facade is considered a plug-and-play facade solution, so capable to provide all this solution directly on site in an easy and fast way for the installation. All the process was designed to be prefabricated off-site and then easily applied on-site. And then the building application, so to demonstrate the effectiveness of this solution. This is the concept behind the RenoZEB facade. How we decide to move? First of all, focusing on the technologies. We decided not to develop specific technologies within the project, but to use on-market technologies. This is because the market is full of very valuable technologies, very effective, and each local clusters have its own technologies. They are well aware about how they work and how they can perform. So the decision was to use what was already available. But how to select these technologies? We design a multi-criteria decision-making matrix useful to comply with the requirements we had inside the project. So we position in this table the requirements in the first column, and then all the technologies in the other column, and we gave to these technologies a rate to achieve final ratings useful to define what was the best technologies to be included inside the facade. This matrix was used for all the technologies mentioned. So for prefabricated window module and roller shutter, and we figure out there were some specific technologies very valuable for our purpose. Then also for the insulation board, that is the integration of ventilation component within the facade. And also in this case, we figure out that a solution was better than the other, achieving our requirement. In the same way, we adopted also for other components for ventilation devices, as well for built-in integrated photovoltaics and related batteries. Finally, for the building integrated solar thermal, so how to provide heating water for building purpose, or hybrid solution between BIPV and building integrated solar thermal. The final consideration after the evaluation of this matrix was this, the result is here synthesized. We found out that these technologies were the one useful to achieve the concept behind the RenoZEB plug-and-play facade. So included a prefabricated window module with a specific product. So for multifunction insulation board, we define what was the best solution for our purpose, and so for everything. As you can find out, these are commercial products. It's nothing particularly new, but they are on-market technologies that we decide to integrate in a single solution. The further step was to consider not only the technologies, but also what are the building envelope limitations for the application of this type of facade. In particular, we define what are the boundary conditions for the existing stock, and also focusing on the two main demonstrators we have applied the RenoZEB facade to demonstrate the effectiveness of the solution. In this scenario, the main components that represent very boundary condition for our design of this plug-and-play facade are mainly two. First, the structural part of the buildings and the openings we have. The idea was to have a low intrusive solution, so to not cause any problem, any particular issues to the people living inside the the department, and these are not components that can be changed. With these two components very in mind, and with the idea to not change anything, we design the primary module. So the one responsible to host the windows, so the opening itself, and after this, all the other modules useful to integrate all the technologies as for BIPV or solar collector, as well as to provide solution for the opaque part. Obviously, this module could be integrated one with the other to provide larger module, so faster installation in case there was some efficiency to do for transportation or shipment and fabrication in general. The second, after this, we define what could be a sort of catalog for the facade modules prefabrication. In any case, we would have designed a unitized facade system, so to meet the plug and play concept, but each unit typology could be different. So we could have a multifunctional facade capable to include and integrate different technologies, the one previously mentioned, as well as to meet different architectural needs, so with different aesthetics finishing. In this way, we could at the same time join the prefabrication advantages, the deep renovation requirement for the specific building, and the architectural request of the building itself. With all these considerations in mind, we went deep inside the Focchi facade system and the plug and play concept itself. What we designed was a facade, a prefabricated panel, which add an additional layer to the existing one. So the existing wall will remain the same, won't be touched by our intervention, and its presence guarantees that people inside the building can keep living inside the buildings, inside the apartment, without change their life. Then we have a cavity. This cavity is useful to host the bracket for the installation of the fabricated panel, as well as to increase the insulation properties of the overall renovation building. Just to mention an example, in the Voru demonstrator, the one you're gonna see in the next day, this cavity was a key element to achieve the highest thermal transmittance target requested, and so it's useful for the purpose to have nearly zero energy building itself. For what concerned the RenoZEB prefabricated panel, the initial idea was to adopt the curtain wall facade standard, because we wanted to comply with the norms and the European code to achieve certification, as well as to have a very high quality product for this type of product. And the main characteristics, the main components and materials included in the facade are distilled, so metal sheet in the back and the front to guarantee that this facade could be tight, mineral fiber inside for insulation properties, and eventually membrane and fiber cement on the outside. After this initial idea, we move to the specific design of the facade. I cannot move. Okay, here it is. And we move to the facade design itself. We decided to eliminate the utilization of the metal sheet. This was something that was requested by specific requirements of the demo partner. They wanted something that could be breathable, so capable to not have moisture problem during the year, and this for sure a good point, and with the utilization of membranes as alternative to metal sheet, we could achieve this solution. Let's say that even in the case in the utilization of metal sheet, we would have complied with the norms. So there will be some condensation issue, but during the year this is allowed by the norm. But with this type of product, we could achieve an higher standard and perform also an innovative product in general for the curtain wall facade, where now the membranes are not so well, not so diffused in the market, and the metal sheet is the standard currently used. In any case, here you can see one of the preliminary design defined during this phase. So we design a facade with a glazing bit, a mechanical restraint to restrain the external finishing. And behind this facade, there were different layers. The first was a membranes, so a breathable membranes capable to resist to wind and to high standard of air and water tightness, the insulation material, and on the back there was an additional membrane. This solution was with mechanical restraint because we wanted to avoid as much as possible the utilization of total silicone, or in general to provide a solution that could be mechanically also disassembled. We designed also a second solution similar to this one, but with a ventilated facade. These include an external finishing, which provide a ventilated facade in the back, and then a membranes. For the other layers are the same. What are the main differences? First of all, the finishings. If we want to have breathable panel, we need to have certain material in the first solution. So only breathable material. Wood, for example, could be one of them, or also some sort of water-resistant plasterboard. In this case, with the ventilated facade, we separate the breathable part starting from the first membrane to the external finishing itself. And this ventilated cavity guarantees us to have the breathability of all the panel. In this case, the external finishing can be all the type of material on the market, so to meet all architectural aesthetics requested by building owners or building tenants and so on. Fiber cement, porcelain tile, glass, wood, everything could be installed in this ventilated facade, as is typical of this technological solution. The RenoZEB panel itself guarantees the performance already defined in the previous design. This was this second solution. So the first one had a mechanical restraint and some limitation in the materials. This is a ventilated facade with no any limitation for the external finishing, and the guarantee to have ventilated facade in the back. These are the results for the Spanish demonstrator. Sorry, moves on. Okay, I can't go back now, but no problem. I show you directly the Volu demo case. So the calculation for the Estonian demonstrator. As you can see, we have no condensation problem. This is relevant. It was one of the requests of the demo partners. So there were no moisture problem inside the facade, no condensation. So everything is in line with the norms and in line with the requirement requested by the project. The same was for the Spanish demonstrator, the Durango demonstrator, the ones situated in Durango. And so we demonstrated that with this facade, we can achieve both in a condition like the Spanish one or the Estonian one, very different for many different reasons, the good result for the condensation issue. This is the final design. This is everything finalized on all the consideration I've already presented. So the ventilated facade, the membranes position, the mineral wool for insulation, the bracket design to be placed on site, and this is the final design of the RenoZEB facade. Obviously, this is a node, a detail of the facade. After this, we define more in detail all the unit typologies. So first of all, the opaque unit. This maximum dimension you can see on the screen depend on the external finishing. We decide to adopt, as for the other technologies, on market external finishing, and for this type of panels, more or less all in the market, porcelain tile or fiber cement and so on, the maximum dimension is usually 1.2 meter. This is considered the dimension, a good dimension for this type of unit, and the height is around 3 meter. This can be some change, but let's say this is the maximum we can achieve with this type of facade. The opaque unit is completely opaque, so it's installed directly on the bracket position on the load bearing structure of the building, and it guarantees to cover the opaque part of the existing building. On the right, you can see the result achieved for the Durango. Sorry, I get back. On the right, you can see the thermal transmittance achieved in the two demonstrators with the target expected by the norms. So we comply both in Durango demonstrator as well as in VOR1 with the requested norm, demonstrate the effectiveness of the solution. The difference you can see from Durango VOR of the thermal transmitters depends on the existing wall. The existing wall is included in the thermal transmitters calculation, and it contributes to achieve the final result. The other unit typologies, these are external finishing for the opaque, but as well as for also the other unit typologies I'm going to show you. So we can include cement board, wood, fiber cement, porcelain tile, and so on with different finishing. Obviously, these are all on market solution. The other unit typologies include the window unit with window and roller shutter included. This guarantees to maintain the same opening, only working inside of the intrados to include and absorb tolerances that can be in an existing building, different than the precise prefabricated solution we have. On the right, you can see the thermal transmitters achieved. Another, sorry, this is the solution of monoblock and roller shutter included in facade. The other, included in this Windows unit, there are also some sensors that can be used to manage the roller shutters, so to manage the internal comfort and energy efficiency in general. This has been developed inside the project with the partnership of Università Politica del Marche and Fraunhofer, additionally to the Focchi facade. The other unit typologies are the solar thermal collector units. So here we include a solar collector with that I show you in applied in one of the demonstrator, in the Spanish one. And also there is the photovoltaic unit, so including our own market product. So here the dimension depends on the product, more or less are around 1 meter, the dimension of the unit, and this is for photovoltaic. This is the prototyping of the facade. For the it's a visual prototype, the very first prototype. Some change occurred during the final manufacturing, but more or less this is how it works, the prefabrication itself with the different phase and the positioning of the panel. Here are some activities by our staff during the prototyping manufacturing and installation. You can see both our prototyping team and designing team validating the solution. And here you can see some units. So the opaque unit with wood or porcelain tile, the window unit, but also the photovoltaic or solar collector unit. In this picture, you see the installation procedure. So we simulated in this first prototype an existing wall. We position the bracket, we pick up the unit and install the unit. The result is this one. This is visual mockup we have here in our facility with the different units, and you can see the layerings we have in the facade. So in the gray part here, this is the existing wall. There is the cavity filled with insulation and the prefabricated panel. On the right, the interdoors for the windows. As you can see, there are different solutions we can provide with different finishing, and so different integration possible. The test and results. I'm going to show briefly the results of the test. We conducted different activities for thermal behavior, heat bridges, acoustic insulation, water tightness, and wind load resistance of the facade, but also reaction to fire. First of all, I'm going to show you the acoustic activities. So there were activities conducted for acoustic insulation performance under the specific test for airborne insulation. No flanking was done because there were the existing facade working for this. To compare the different facade, we design the acoustic test using a sort of simulation of existing wall, a one brick wall, to simulate the existing facade. This is the test. 3 configurations were tested. So the existing building envelope only so the one brick wall, just to have a sort of benchmark for the existing wall. Then we test the configuration 2, so the existing building plus the curtain wall installed, and the third configuration is the existing building plus the curtain wall installed, but closing the opening itself, because obviously in the first wall there were no openings, just to have a benchmark with only wall, but this would cause in acoustic test some issues. So we try to compare configuration 1 and configuration 3 to have similar and comparable results. The result demonstrates the effectiveness of the solution. So the reference you can see is the configuration 1 and 3. So considering no openings, we can improve the facade itself. The configuration 2 demonstrates the effectiveness solution, but differently from the configuration 1, we have an opening. We included an additional, so if we had done the same also in a configuration 0, so a brick wall with an opening, the decibel of insulation will be much lower than the 40 decibel, and so we achieve a very good result for improvement of acoustic insulation. The other relevant test was the performance mockup. So we went to accredited test chamber for the test, and we designed the test to comply with all the unit topology we had and to test for all possible application in demonstrators. Different activities were included in the method statement of this test. So air permeability, water tightness, wind resistance, but also impact in different finishing. This is the test itself, the installation, but also some specific part of the test. This is the depression test. As you can see, the membranes move out in this case because it was positive pressure, but in the pressure case, they were on the other side. These are impact tests, both in external finishing, but also in windows. So we test both the material, but also the interface we design and manufacturing inside the facade. Here you can see another test conducted during the validation activities. Just to give you the idea about the, okay. I get back to the presentation. Okay. There were some videos, but I cannot show you now. Here the results. We had everything accredited by an external entity. So the results here were in line with our expectation. We designed innovative facade solution tested for the curtain wall facade norm, so very effective for the market. We demonstrated the safety of the solution, and we could achieve also the certification itself of the facade. For what concerns the fire mockup, this is something not included at this moment in certification of curtain wall facade, but we wanted to understand the behavior for the facade. So we tested in SBI test the facade where there is air inside the overall building envelope of the new building. So we test the external side of the RenoZEB facade, the ventilated cavities to the internal of RenoZEB panel, and from cavity between the panel and the existing wall to the RenoZEB panel itself. The other additional two tests could be conducted, but they would have tested only the external finishing, so not something developed within the project or the existing wall, and we cannot work on the existing wall. The tests were designed in these three configurations. So from external side to RenoZEB facade, from ventilated cavity to internal RenoZEB panel, and from cavity between RenoZEB panel and the existing wall, and the RenoZEB panel itself. Here the test. So the SBA test is a small furnace that achieves temperature of 300-350 degrees. We test everything, and the results were quite positive considering the different material we used. There were some issues related to design of the test itself, but generally speaking, we can guarantee a facade that is in line with external finishing. So we use from outside to inside an external finishing in class A. We can achieve a class A. Otherwise, obviously, if you want something good, the class E is the one used, but it depends on external finish you want to use. We can protect with this external finishing class A the internal layer that can have some issue because they are plastic membranes. At this moment, we are working for implementation of this solution using some innovative membrane in class A or B that can be valuable to have a higher classification for reaction to fire. The alternative is to use metal sheets for the facade itself, and we won't have any problem of reaction to fire. So it's a valuable alternative. Other tests were done inside Cubi in Tecnalia in Spain. So all the installation process was validated and was confirmed, was used also for the training, and the energy performance were validated. Just to give you last part of this project, on the base of existing building and the survey conducted, the design of RenoZEB facade is conducted, and then a detailed design for the RenoZEB facade system is done, including all the shop drawings useful for the procurement phase, for the installation in our facility, so to have everything in an industrial way. This is the result for the Spanish building. As you can see, it's quite valuable from our side. Very beautiful building with the performance very high and with the different solution. Here you can see the opaque typologies of the facade, the windows facade, but also photovoltaic and solar collector. The same procedure was adopted for the Estonian building. You're gonna see later on. So the existing building, the general design by the architect, and then the detailed design for the facade itself. And the result is this one. So we change the building from an aesthetic point of view. We increase the performance with consequence on the energy consumption, but also the property value itself of the building. Conclusions. The plug-and-play facade is a valuable technology solution able to integrate different solutions for deep retrofitting. Can be customized, so this is very valuable using product on the market can provide a high quality due to off-site prefabrication that guarantees more precision and tolerances very tight, can guarantee aesthetic and functional integration during on-site activities. Once the people on site understood how to work the curtain wall facade, it's very easy and time-saving the installation itself. The user inside building are very low, only few problems during the site activity because the work, all the activity of renovation is from outside. It can be adapted to different climate condition, building tolerance or energy needs. And generally speaking, is a curtain wall facade that demonstrates effectiveness for the building renovation. That's all. Thank you.
Okay, thank you very much, Alessandro. I would invite the audience, if they have any questions, please type it in the chat box, or simply you can ask your question to Alessandro as well. So we are giving the opportunity for questions if there. Alessandro, we have a question in the chat box. Can your facade also be applied to single family buildings?
Well, let's say that generally speaking, the answer is yes. It's a technology that can be adopted also for that case, but probably the dimension is not so relevant to achieve a cost-effective solution. Probably more other technologies for small building as single-family building are more effective from a cost point of view. When we work on multi-apartment solution, here the plug and play and RenoZEB facade can have advantages also from economic point of view. Obviously, for what concern the performance itself, it's more or less applicable also in single family building. Another question is what would be the minimum square meters to make it cost effective? I would speak more about the number of stories of buildings. Generally speaking, curtain wall facade is considered valuable for buildings from 3 stories. That can be an effective parameter to consider this plug and play facade solution. So from 3 meters, from 3 stories and up, it's an advantage solution to be adopted. So let's say we are speaking about more or less 3 stories, so 6, 10 apartments and more. This would be an effective dimension for the building. Another question is, what about the European Union-wide shipping? Is that complicated? Not complicated, but there is a matter of kilometers to be done. So the shipment is optimized for the curtain wall facade itself. It represents obviously a cost to be considered. So probably the plug and play facade is can open to open solution also for the utilization of this concept, the design by some licensing possibility by local partners, so to reduce the shipment issue and generally to reduce the impact also on the environment, to do thousands of kilometers to be run to move from Italy to everywhere. Obviously, we can do it. We normally do it with our market, but probably if you want to achieve very high diffusion of this solution, some different business model can be adopted for the spread offering the plug and play solutions.
Okay, great. I guess if we have no more questions, we would go to Tecnalia presentation.
Yes, hello. I'm Asier Mediavilla from Tecnalia. Can you hear me okay?
Yes, yes, we can hear you.
Okay, so how will we do it? So shall I share my screen or will you pass it? Or? Okay, can I move the slides myself?
Yes, you can move yourself. Can you control it?
Yes, I am.
Yes, is it okay for you?
Okay, yes. Sorry, I see the control now. Yeah. But it's going a little bit slow. Okay.
Yeah, it's late.
Okay. Sorry for the delay. Let's hope that it works. So hello everyone. I'm Asier Mediavilla from Tecnalia, and I'm going to present the developments done in the RenoZEB platform and well, the associated collaboration workflow. So let's move on. So the idea behind is that the idea behind is that the energy renovation process is a very complex process. So there are a lot of stakeholders participating in different phases. And well, already in the RenoZEB project, there was a decision-making methodology developed that provides a way that how different actors can collaborate and want decisions taken on each of the different phases. So in this way, the collaboration platform can be seen as the backbone where different actors collaborate. So in the left, we can see a timeline view. So we have the plan, design, construction, and different phases, and how different actors can share information, make decisions, and use the platform for the decision making. And also from the perspective of the as an integration view on the right, we can see that different actors or different software tools could even integrate the results into the platform. So we can see the platform, well, the core concept of the platform is that the BIM. So we can see the BIM as a process, as a verb where we have different actors, as we see, that collaborate in the process and can share information, share issues, assign tasks to one each other, or even define different scenarios or alternatives with some KPIs taken from different tools used in the project or from external tools, and then make rankings in different scenarios, which is better, which performs better according to some user-defined criteria. So we will see them afterwards in a demo. And in the right-hand side, sorry, you can see that the BIM can be seen also as a as the data model of the project with all the information related, and we support to visualize the BIM models in a web viewer, and also to make different queries and filter the data associated by providing different thematic views and different color charts, or even to visualize different BIM formats. So the IFC model, also the final render, as you can see in the left hand side, and also to connect external tools like as we are going to see a short demo with Cype tools. So this is a very complete view. We are going to see some specific things about here, but in brief, there are different actors that can collaborate in the platform, and each color denotes more or less the functionalities or the different types of functionalities supported by the platform. Some are embedded functionalities like create scenarios or visualize models and so on. Some tasks are externally done, like the creation of BIM models or renders and so on, that can be imported into the platform. There are also some tools that are not originally from the RenoZEB platform but can be embedded as an built-in or additional or extended functionalities of the platform. And there are also external tools like Cype tools that can even connect through the defined API. So I have no more slides for the moment. So the best thing is to watch it in action. Perhaps, I don't know if you can see the letters very well, but well, we will see first how you have different users. So if you log in as an administrator, you can handle all the users in the platform. So you can create a new users, assign them a role into the platform, and so on. Let's move on. You also have, I will stop a little bit here. You also have, let's say, all the KPIs that are defined in the project. So the platform lets you define or to manage like a dictionary of KPIs. So you have these KPIs that are built in already are the ones defined in the RenoZEB project that are used for the decision making, but you can select one KPI, edit, or even we can create, as we can see, well, we can see here how to edit or how to assign the information of the KPI, for example, the domain, energy, environment, the type of unit, the value, and so on. And if it is applicable to the whole building, and well, you could even associate documentation or related information to the KPI. Let's move on a little bit. Now we also support like a hierarchy of KPIs. So for example, for the energy KPI, we are creating, for example, the total heating, which is like a KPI, which is let's say a child KPI. You see the first one that has an arrow that if you click, you see the hierarchy behind. So the energy can be split, for example, in total heating, cooling, and so on. And well, and you can do for all the information in the platform, you can also support this kind of hierarchy. You can see also here that there are some KPIs that are not numeric, but are, for example, a list of values like the energy performance certificate that can have like a ABCD, or the building appearance that you can define this KPI as a collection of values like bad, good, regular, excellent, and so on. So it's not only that you can compare numeric information, but also, let's say, more qualitative information. Now we are logging as a particular user. So if I log in with a user, I can see all the projects where I have been invited, and we can have different roles. So the project creator can invite or define other users into the project and assign them a role. So you can be only a viewer, or you can have addition roles in the project, in which case you can add or modify the information contained there. We can see here how you can manage all the resources, or let's say the files or the information associated to the project. We are now seeing how you can change the language. So the platform is already translated into all the languages represented in the project. For example, now we are seeing the Estonian translation also in the menus in the top and in the right. Yeah. Let's move on a little bit. So for example, now I have logged in as an invited user. So I have not permissions for editing or for uploading information. I can only view what's in the platform in this case. For example, that could be interesting for if you can invite, for example, the owner, the building owner, and let him view how the project is going on, or how the rendering, the alternatives proposed are look like, or he or she can visualize it in the platform, but perhaps we don't want to give them the permissions to modify, to create, or to edit the information. Yeah. Well, we have seen that we can also upload documents, photographs, and other kind of information here. For example, now we are uploading a photograph for the Volu building, and once uploaded, we can click and see it already. So we can manage all type of information. Also, we can manage, we can organize the information in different folders or different scenarios, so in whatever name we call them. So we have here the Volu project organized in the original, with the original drawings as they have been uploaded. We also have a folder for the definition of the BIM model before renovation, after renovation, so we can organize all the information and download it. And also, in the case of IFC models, so in the case of BIM models, let's say, we support, as we are going to see right now. Let's move on a little bit. So this is a file, a PDF, the plan of the building. So for example, now one of the files is a BIM file. So when you upload a BIM file, there is a particular icon that tells you that this is a BIM file, and if you click on there, automatically you can visualize the model in the viewer. It gives you the options to select what elements to see or to hide, or, well, it's perhaps you have already worked with some BIM models, but this one is based on free technologies, and you can view it on the website, and you can integrate on a custom application. One of the functionalities we also provide, let's move on. Yeah, for example, now we are also seeing the BIM model of the renovation project, the Focchi facade developed by Focchi. So this is the view. This is not the render we are going to see right now, but, well, as you can see, you can combine different BIM models in the viewer. So we can see, for example, the building before and after. So these two icons in the left. Also, we support a viewer for the GLTF format, which is a rendering format that in this case has been also created by Cype, and we have developed the viewer where it can be also seen online, for example, to share with the client, or to, yeah. We could also create a rendering where you have the original building and this rendering attached, so that to compare how it's going to look like. Let's move on a little bit. yeah, on the right hand side, there are the, when you click an element, you can see all the information on the left hand side panel. And well, for example, we can also have, this is the query or auditing functionality. So you can select a property in the BIM model and color it according to a property. In this case, for example, the area of a room, and you can select the ranges and the colors that you want to display. For example, that could be very useful if you link the information of each room or each element with energy consumptions or with energy related data or whatever. We could automatically make a display of this information, or even have like a two coloring displays, one the consumption after and one before, for example. And we also have the functionality for filtering the information. For example, in this case, we are, for example, filtering or telling or asking to the platform to provide us, for example, which spaces have a floor area higher than a certain values, for example, higher than 20 square meters. And then these elements are highlighted in the model. For example, we could do the same with energy consumption or with some relevant information which is important for a decision making. We could make some filters and see which element fulfill this information, or put it elements in red and green depending if they fulfill or not the criteria applied. Yeah, what we are seeing now is the scenario management, or let's say the KPI comparison tool. So you can create different scenarios. For example, imagine that you want to compare the current situation of the building with 2 or 3 different alternatives. Like one alternative could be to put the Focchi facade with some solar panels for heat water, or for solar collectors or whatever. Or another alternative could be another type of solution. So you could create different folders, different scenarios for these alternatives. And then if we go to the comparison, we see that we cannot compare anything yet, because first we have to define the targets of the project. So we have seen in the beginning of the presentation how the administrator can create or define different KPIs, and now the user, that could be, for example, the building owner or someone that acts on his behalf, that selects here with a checkbox, with a click, the different KPIs that are applicable, and gives these KPIs a score. For example, you have to tell which KPI values are scored as 0 and 1. So basically what you are telling the application is the different values for these blue shapes. So you can have KPIs that are increasing. For example, energy reduction, the higher is better, but energy consumption, the higher is worse. And comfort temperatures, you have some central good value and then bad values in the stream point. So all this information you are comparing into this, or you are defining into this text box in the left. So you give, for each value, you give this value and a score. And in the green box in the middle, you put the target or your reference value. For example, my target is 100 in CO2 emissions, or 30 kilowatts per hour per square meter. Also, we can see here how you can put values to, for example, to the appearance. We can see that bad appearance is 0, excellent is 1, and all the values in between. So, of course, these kind of KPIs are very subjective, and well, it's very difficult to see what, or to define for a given scenario what is bad and good. But in the case of energy, it's more. Yeah, it comes from a simulation or for a tool, so it's more accepted value rather. Well, now we have defined the KPIs, but we have not the real values for these scenarios yet. So Ideally, we also provide a KPI for external tools to automatically take these models, make the calculations, and upload from a plugin or another tool their values. But for this presentation, we can also do it manually. You can click on edit and edit the different values manually. And once all the values are entered, you can already compare. So for example, in the left, in the KPI weights, you are telling which of the KPIs is more relevant for you. If you prefer the energy reduction, then the alternative 2 is scored higher because it has the highest energy reduction. But if for you another KPI is more relevant, or if you have a mixed priorities, then you can move these sliders to the desired configuration, and then all the scoring is recalculated according to that. As we tell you, this demonstration is done a little bit manually, but we are working also on how to automatically integrate or provide all these values from external tools. For example, you have a simulation tool that automatically calculates energy consumption, so whatever values, and automatically uploads the scenario values to the platform. But you can also do it manually. Now, for example, we are creating, or we are telling the platform that we want to compare another additional KPI not foreseen before. And we will also create some additional scenario not foreseen before. And since we don't have values, we see all this red line telling us that, well, there are no values calculated. The same with the scenario. So if we create a new scenario, of course, we will not have values calculated yet. And in the comparison chart, we will have a lot of red marks there. So this scenario in particular will not be part of the comparison below, but you can just click as before and create all the values and so on. So it's a very flexible way to create as many scenarios and as many KPIs as you wish, and to rank according to your priorities. Now we are seeing how to integrate different ways of integrating external tools. For example, when the tools are web-based, like the monitoring system developed also by another partner, by Hypertech in this project, in the RenoZEB project, we can embed or access directly from our platform. So we have a link in the left. So you click there, you can access to the monitoring tool developed in the project and access to all the functionality. So from the platform, we can control which user can access for which project to this functionality, but it gives an integrated overview of all the project because all the tools can be integrated. Now I will show you just a little demo about another tool that we are working in another European project, in which in a very initial stage of the project, when you don't have the project model, for example, you can create one from scratch. Now we are seeing, for example, this is Google Earth, so that where you can pick the dimensions or orientations of the building. And now in the top bar of the platform, you see the IFC utils, where we have developed a very simplified parametric generator of a very conceptual building mockup. So for example, we are entering the data for the Boru building, which is like shape 5 here, and we enter the dimensions, the side lengths. We can also pick up the location in the map here. So we put Boru, and well, it finds the location automatically. We can select that our geolocation of the building is this one, is the Boru building. And also, well, when we don't have still a district scale model, we can also put some dimensions about which buildings are around our building. And yeah, and if we click, so we can put the distance and the height of the neighboring buildings as a conceptual shape. And if we click on create, then it's processing. So we can also create as a KML format a reference view. And once it is done, so we can see that directly from Google Earth, for example, as a proof of concept that the building has been created in its proper location. But we can also offer from the platform a different, so we can upload the created information into the platform, both the IFC and the georeference model, and all the information is visual in the platform and can be used by external tools, for example, for providing or for performing a very conceptual energy simulation or whatever. Now we are adding this information into the platform, and we can see it both into the bin viewer. So this is the conceptual model created. And for example, we can make the same functionalities as before. We can query for example, the building or provide some colors according to the area of the wall, so whichever property. And yeah, we can also see the geolocated view with a georeference viewer. So finally, we are seeing how to integrate also external tools. So for example, Cype has developed a plugin. You see here in the top some icons. We can see project and so on. So you click there, and right now from Cype tools, we are connecting with a username to the platform, and the user can see all the projects where he or she has been invited with all the informations, bin models, and so on. And they can be directly accessed from external tools, in this case, Cype tools, and uploaded back into the platform or even used for calculations. And yeah, I think that was the last part. So yeah, basically the summary of all this is that the platform can be an integration point both for user collaboration, so that different users access to different information from different projects, but also from software tools perspective, different tools can connect to the platform and can be embedded into the platform to provide enhanced functionalities for the platform. And well, our next challenges with the platform is to provide mechanisms from automating all these data transformation processes, so that you can automatically convert some GIS model to an IFC, or from an IFC you can automatically generate some renders, some district scale information. So some aspects that has been demonstrated here manually to be able to do it in an automatic way. Well, and that was everything. So thank you all. And any question you have, you can just raise your hand, or I could also provide my email and you can ask me afterwards.
Thank you, Asier. In fact, we have 3 questions for you. So the first one, is the platform be available after the project ends?
Yes, well, we have already in a public address, and well, it can be there for a long time, so it's no problem for that. We can, if anyone is interested, we can give you some demo user and password so that you can enter. So from that point of view, yes.
Okay, the second question. Did you try to add ventilation or HVAC in the BIM model?
Yes, well, I think that with the Voru demo case, we have not tried yet. If you have some HVAC BIM model, you could just give us to make a try. But we have for other buildings or for other examples, we have combined both HVAC for example, the same way we have seen two models at the same time, the renovation, so the building before and after renovation, we could combine different BIM models in the viewer, like the architectural view, the HVAC view, sensors, so any different layers. So the viewer already supports this, yes.
Yes, so I guess the second question is a little bit related to what you said. Did you try to add the viewer for the planning construction process purpose? So yeah, if there is a viewer, so I guess you bring through it.
Yes,
right?
yes, we can support also the construction phase, but well, in the RenoZEB project, we have more focused on the preliminary design and analysis phases, and not so much applied to the construction. Well, we have applied to the monitoring phase by embedding also the monitoring viewer, and it can be applied in particular, since it's a data sharing and information sharing platform. It could be applied to any step of the process, but we have not used yet for the construction phase.
Okay, thank you very much. I just want to let you know that we have the link in the chat box for the collaboration platform, and we also put the link for the tools. So if you want to access all the RenoZEB tools that we present today, you just go to the link in the chat box. So now we move on to Ani Ferreiro from Cype. Ani, the floor is yours.
Hello, can you hear me?
Now we can hear you.
Okay, I'm gonna ask for the control again. Maybe give me a minute, please. I don't see, all right. Okay, so thank you everybody for being here. My name is Ani Ferreiro and I work at Cype software. And what I'm going to present you today is a set of tools for renovation, okay? This set of software tools works in BIM as it does the platform that Asier has shown you before. And what we want to provide you is with a set of tools for BIM modeling and energy efficiency calculation and project and construction site management. So first of all, let's move to the next slide. We are providing these integrated solutions that they are composed by various tools. No? The first of them is IFC Builder. This is a BIM modeler, and it's a really easy to use BIM modeler because it's really prepared to create this BIM model and then an energy model for calculation. This tool is free, and you will be able to download it later on. I will show you where. Also, we have, I don't know. Okay. OpenBIM Focchi facades. This is a software that we have developed under this RenoZEB project. And what this software does actually is to create this BIM model of the facade, or this pre-design of the facade. Then I will also show you Cype term, E+, and Cype term improvements. These two softwares are directly connected with RenoZEB platform. that Asier showed us, and these softwares are related for, are made for energy efficiency calculations and CO2 emissions. At the end, I will show you really quick Archimedes. Archimedes is a software for budgeting and job control, construction control site, etc. All this software is working under Cype environment and is working under IFC format. What does it mean? That the software exchanges information with the IFC standard format and is capable of exporting and importing or reading this information from the various software. Also, the connection with the platform, the RenoZEB platform, is made through this software, this format. You are going to be able to download all this software from the RenoZEB webpage. You have the link, but also you are going to be able to download it in Beam Server Center. That is the main environment for all this Cype software. I'm gonna show you later on where you can download it, and it's really easy. Okay, let's go for the next slide. Okay, so just for make it easier, I have divided this software in 3 parts because it's addressing 3, let's say, challenges or problems of the process. The first 2 softwares, IFC Builder and OpenBIM Focchi Facades, are related to the building itself and the facade design. So the idea is that the architect will be able to create this BIM model of the existing building, and then add the design of the facade. I'm gonna call it this pre-design, because after all, Focchi will make a specific design panel by panel, But this pre-design where we can, let's say, imagine or pursue how this facade is gonna be put into the building. Then the energy efficiency simulation software, that is Cype Term Plus and Cype Term Improvement. Cype Term Plus, you're gonna be able to do this simulation. This software works with Energy Plus Engine, and then Archimedes. Okay, just some information about the software here. These 2 softwares are free softwares, and you are going to be able to create this BIM model of the facade and the building and the existing building for free. This BIM model also, with this IFC Builder software, is capable to read point clouds. So an important part of this project has been to scan these buildings and then to put these point clouds inside the software to be able to create as a reliable model as possible. And for example, in the energy efficiency simulation, what it does now, the RenoZEB model is capable of simulating with Energy Plus Engine, and you will have a catalog of solutions that will help you to address this renovation easily. And same for bill of quantities and Archimedes. It reads not only the BIM model, but is capable of reading BC3 format, which will be that is a format for quantities, sorry. And well, here you will be able to do the job and site control, Gantt charts, etc. Okay, what is the workflow of this process? So first of all, the architect, or even though sometimes an engineer could do this BIM model with IFC Builder. IFC Builder is capable of sending the BIM model or the information of the BIM model to OpenBIM Focchi Facades. all this information together is going to travel to Cype term E+, where we are going to develop the energy efficiency simulation of the facade, or maybe in this case we are using RenoZEB plug-and-play facade, but we could do other type of renovations, like with internal insulation, with aesthetics facade, etc., and compare the performance of various of these simulations with Cype term improvements. Okay, this also can be done at the platform, at RenoZEB platform, and I think maybe it's more interesting that in Cype term, but you also have this software to make this comparison. And then at the end, all this information will travel and fly, let's say, to Archimedes, where you will be able to do the budgeting and job control of the construction site. Okay, also just to remember, the Cype term improvement plus, the Cype term E+ and improvements are connected to RenoZEB platform, so you're going to be able to upload and download directly information from the platform. And yeah, okay, so that's more or less the workflow. And just for you to see, this is the Estonian demo case. You can scan the QR code if you want, and you are going to be able to enter to the project or BIM project of Estonian demo case. This is a really interesting feature of Cype tools, because it's gonna enable you, for example, to share the information with your clients, to share the information easily with other engineers, etc. This Estonian demo case, as I said, has go through various steps. No, first of all, we did this scan, and we did this laser scanning, and with this laser scanning and the 2D plans, what we did was to create a BIM model of the existing building. Why it was so interesting to have the laser scanning? Because when you put the two of them together, the laser scanning and the 2D plans, you realize that sometimes the reality doesn't fit exactly the plans that you have. So you can make a more accurate BIM model that only with the 2D plans or double G plans that we had in the past. Now you have the opportunity to make this comparison between both of them and be more precise, because you want to, renovate this facade that is going to have panels that are really precise. Okay, so we have created the BIM model. After that, we have used OpenBIM Focchi facades, and there we have do a pre-design. I like to say that this is a pre-design, because at the end, Focchi takes a big work, designing the final facades, but this is going to give you an overview of how the facade is going to fit in the building, how more or less approximately could be the price of this facade, and what will be the energy savings for this facade installation. And then at the end, we bring this BIM model, with the facade to Cype term E+, and what we did there is to make the simulations. Basically, what the program does is to give, let's say, a construction system for each of the elements, for each of the elements of the building. So the roof, the walls, the slabs, the HVAC systems, the water systems, etc. So it can simulate what it will be the performance. Again, here with Cype term improvements, you can see at the end which is the performance before and after renovation, and not only before and after renovation with the plug-and-play facade, but to compare with other solutions, or to be able, even though with the same solution, okay, I have the Focchi facade, so let's add a roof insulation. Let's see if that performs well or not, or maybe it's not as necessary as it could be. And if you change the heating system, it will be better, no, or it will be improved more than if I put insulation in the roof, for example. Okay. So this program will allow us to more or less see what we are doing and which will be the better solution to choose among different performance among different solutions. And then you will bring this information to Archimedes. Archimedes is these programs that I have shown you now, IFC Builder, OpenBIM, Focchi, Facade, and Cype are quite easy to use, I will say, and quite easy to be learned. And then I will, at the end, we will move to Archimedes, and Archimedes is a little bit more complex program because it does a lot of things, no? It does from the bill of quantities to the construction site control. You have to add more information here, but still it's a really interesting program, no? I think this program is more for execution part, where you have already your facade or your project approved or your renovation project approved, and you want to execute it. So this program will be for that part, and it's more complex, but it's still really interesting. As you see here, for example, we have created a really simple Gantt charts of the installation or the price of the renovation for the facade. Again, I will say this price is an estimated price, and it will depend, as it was said before, of the shipping, etc. Maybe I can have the control. I don't wanna. Okay. Can you see my screen?
Yes.
Okay.
Yes.
So I want to show you, before showing you the programs, I want to show you really quick the environment where Cype works and where you can download the programs. If you go here, binserver.center, you are going to enter our environment, and if you click Store, here you are going to have access to all the applications of Cype, but specifically to the ones of the project. So, for example, if you put here Focchi, you can have access to the Focchi program. Okay, you can download it. You only have to make a user that is completely free, and most of the softwares of this project, RenoZEB projects, are also free. But if you want, you can, the ones that are not free, as for example Archimedes, you can ask for a try. And you here also will be able to access to the resources. Okay, so you have here a small course of Focchi facades, same for IFC Builder, Cype term, etc. You're going to be able to find it also in RenoZEB webpage. I'm going to show you because I think it's interesting. In the case that actually you want to download the program, you go here to training, tools, and here you will have all the training tools, also the collaborative platform access. So here you can access to, for example, IFC Builder, the tutorial on YouTube or Udemy. I think the tutorial is really interesting. They are quite easy to see, and just if you want, please download the program and access to the tutorials and see if that fits for your process, no, of renovation. Okay, so that said, I'm gonna briefly show you the different software. I'm gonna start with IFC Builder. IFC Builder is a really, if you are not aware of BIM, or if you are not inside of BIM, let's say, it's a really easy program to use. I will say it's a really good program to enter BIM. Maybe it's not the bigger program or the program with more capabilities as it could be Revit, Archicad, Allplan, even though we have other more advanced BIM modeler called Cype architecture that is free also. But I think it's really interesting also for engineers that maybe that doesn't have that 3D modeling, or they don't know how to model in 3D, let's say. And what you basically, or what we have done here basically is two things. First of all, we have entered two types of data here to create the renovation model, the point cloud data, okay? You can see here the building in the point cloud of the building, okay? And the 2D floor plans also of the building that are here, okay? Let's open, this is P2, okay? Let's go to the P2 floor and let's open P1, okay, yeah, it's open. So basically you have these two information data to work with, okay? And what you are going to do here is a really simple program. You have walls, you have floor slabs, you have openings. So basically you are going to start developing this model in 2D. Here you have the 3D view. I say this program is really easy to use because it's a 2D program that creates 3D models. So for people that is more related with AutoCAD, let's say, it will be a first step between 2D modeling and 3D modeling, and in between step. So really easy. I create a type of wall. I have already my type of wall created here, and just introduce really easy the information. And this way we are going to be able to do this project. I don't know what happened. Okay. After that, you export to the next program. No, once I have already my 3D model done, what I want to do now is to create this facade, no, or to see how this facade is going to be able to perform. So I come here, no, I'm gonna delete a little bit. I'm gonna show you really briefly each of the software. You will have again the information or the tutorials in YouTube and Udemy. So if you really want to learn how to use this software, you just could go there, no? So here in this Focchi facade software, we have the Focchi panels, no? Opaque panel, the technical system panel, solar collectors, the photovoltaic panel, and then specific panels for the windows, for fixed single and double windows. Also, in the case that it will be neither corner panels and door panels. So the idea here is, okay, I have already my BIM model and I came here and I want to see how this Focchi facade will fit in a pre-design. Again, I think I want to put the point in this, that this is a pre-design, and I will come here and say, okay, let's put this, I'm gonna put a linear panel units, and I'm going to use photovoltaic unit, or let's start with a opaque unit and with a timber finish, for example. So I'm gonna be able to click here click here. Sorry. And create those panels, okay? This way I will be, for example, same for the photovoltaic unit by clicking here, let's click here, okay. So I will be introducing these panels, no? The idea is once you have created all this V model, for example, you will realize after when Marty shows you the building that actually the panels, the solar panels were only located in the sorry, I think in those facades, not in all the facades like this pre-design, no, because we realized that we didn't need it, or the performance of the solar panels and the solar collectors were not quite good, so it was not necessary. But this is a pre-design where after that you can obtain a list of all the panel description, no, that you can circulate to Focchi, so they can have an idea of this first pre-design. And also when you export, you are going to export information in this BC3 format that will allow to make this bill of quantities and job control. Okay, so I will export again. And then I will move to the next software, that is Cype term. No? In this software, actually, what I'm doing is to load these beam models and to calculate the energy efficiency and CO2 emissions of the building. This software is also quite simple to use. Here, the program is gonna read all the external partitions, underground walls, floor slabs, etc., roofs, glazed openings. And what I'm going to do here is to give them a definition, well, spaces, etc. We are going to give them a definition, and we are going to define one by one what is each of them. So, for example, all the spaces related with bedrooms are occupied spaces, and we will have this ventilation and lighting. You will see all the programs has, like, let's say, shortcuts. So I can say, okay, this is a residential space. Load me the information, please. It's gonna be the same that is loaded right now. To help you know this energy efficiency calculation, but also you will be able to manage all of this information manually. For example, another interesting thing of this project is that it's providing a catalog. So for the exterior wall, you will be able to go to here to RenoZEB, and will be able to load different solutions. I'm not gonna load it now because I have my Focchi facade solution right now here implemented, and I don't want to change it. Same for all. Okay, so you will be defining, for example, for each of the apartments here we have defined a radiator and a HVAC system. And there you will have a really easy way to be defining all this information, domestic hot water systems, etc. Okay. After you have done this definition, what we have done is first to create a definition for this pre-renovated building without the Focchi facade system that you can see there. And then we have created a renovation. Well, after the pre-definition, we have created a definition with the Focchi facade. And then, for example, I'm going to show you in Cype term improvements now. Also, adding, for example, new HVAC systems or adding new heating systems. So you can make changes and compare them to be able to see which is the system that is better performing, and it makes more sense to change in your renovation and your renovated building. Okay, here you are going to have the analysis. Sorry, because this it's a little bit slow loading the analysis. This analysis is for demand and consumption and also CO2 emissions. Just wait a second, because it's generating again the reports. So once you have defined everything, you go to analyze, and the program will run Energy Plus engine that will analyze the building. Just give it a minute. It's not so much time. Maybe why it's loading, I will show you Cype term improvements plus. That what it does is take these results that I'm going to show you here in a minute, that the program is loading, and is capable now to compare them. So we have this initial situation where we have created a project here in Cype term plus with the initial situation, and we have export the improvement measure or the initial measure. And then here we have another simulation only with the Focchi facade that actually performs quite well alone. And then we did another simulation with a roof insulation in new HVAC system. And actually, it was not so much sense to change the HVAC systems. It will be so much sense to change the heating systems. As for Estonia, it's quite more important, the heating system. I realized after doing the simulation that maybe doesn't make too much sense to change this information. So here you are going to have all the information exported from Cype term, let's say. Here, okay. So here you are going to have heating and energy minimum temperatures apartment by apartment, cooling maximum temperatures, and resource apartment by apartment or space by space. And all this information is the information that is going to be uploaded to RenoZEB platform and also to Cype terms E+ improvements. When you export this information to improvements, you're going to be able to obtain also like a more simplified list of comparison. You can add also here information about the net cost of investment, etc. But and obtain the return of investment. But here, as you see, for example, the performing with the Focchi facades is doing really well in the cooling. It's improving the heating and the sanitary hot water. We didn't do anything with the lighting in this case, so the lighting is the same. And you can see, well, the performance for each of the systems, the kilowatts per year, and also the CO2 emissions. And for example, this was another measure that I took, but it was not performing so well. So this is very interesting to see, okay, so maybe it's better to change the heating system, and it's not necessary to insulate the roof because it's under a non-occupied space, so it's not going to change so much the performance of the building. And again, just for you to see, as Asier has said, sorry, I didn't want to go to floor plans. well, here is another part of the software, but here you have the connection. You see RenoZEB projects, or if you create a user in the RenoZEB platform. Wait a minute. You're gonna be able to connect to the platform. Now it's calling to the platform and access, for example, the various projects we have and the data and download the BIM models, etc. Okay, so here you have this direct connection to the platform, also to upload this information to do this comparison in the platform, that I think is quite interesting, because for example, here in improvement, you cannot see in the 3D model the performance, but the platform is like more complete, I will say, and it's really interesting to have all this information there, also to download this information from there to be able to complete the project. And just to finish, because I'm talking a lot, I'm gonna show you really quick Archimedes. As I say, that Archimedes is a more complex program, and we could be here explaining this program for 3 or 4 hours. You're going to be able to find information also online. But basically, for example, here, what we have loaded, really simple, is the BC trees from the Focchi facade, that I say it exports from Focchi facade to obtain an estimation of the renovation. This is, I say, was a pre-design. For example, in the final renovation, you will see that this bottom part doesn't have panel, neither this top part or this front part, because we look for the better performance of the building. And here you're gonna be able to create price structures, bill of quantities, construction, location codes, for example, for all the part of the construction management. You are gonna be able to create a Gantt chart, location codes, etc., etc. This program is really interesting, but I think if you want to go deep on it, maybe it's good to see some tutorial on internet, because I could go for hours with this. And thank you very much. I don't know if there is any questions in the chat that I can answer.
Thank you, Annie. No questions at the moment, but please, if you have any questions, you can write in the chat box. We have a couple of minutes now. So perhaps if we wait a few seconds, otherwise we change to the next presentation. Well, meanwhile, yeah, I'm going to share my screen again. Okay, can you see my screen?
Yes.
So if we have no questions, so Martin, the floor is yours now. The presentation will be in Estonian.
Hello, everybody. I will keep a presentation about the Estonian demo in Estonian, and I hope our translators can translate it to English. Nii, tere kõigile. So, okay, yeah. It's a little bit slowly. Ja, see on natukene aeglane küll, aga okei. Ja, tere veel kord kõigile ja kena lõunaaega. Püüan siis anda ülevaate sellest demo hoonest, mis siis oli rekonstrueeritud või sai rekonstrueeritud siis RenoZEB projekti raames. ja arvestades kõike juba eeltoodud ettekandeid, siis väga paljuski kasutati selle hoone juures just neid tööriistu, mis said siis projekti poolt välja töötatud. Ma tänan ka kõiki eelnevaid ettekandjaid muidugi, aga siis nüüd asja juurde. Et Võru hoone on siis asub Liiva 26 aadressil Võrus. Ütlen veel nii palju ette ära, et kes soovivad seda hoonet vaadata, siis 16. juulil kell 11–12 põhimõtteliselt saab käega katsuda ja oma silmaga vaadata, küsida küsimusi selle hoone kohta. Nii hoone esindajad on kohal kui ka hoone ehitajad on kohal, et siis saada otse informatsiooni ja kontakti, siis kuidas selliste eeltoodetud paneelidega renoveerimine Võrus läbi viidi. Nii, aga hoonest siis nüüd. Hoone on ehitatud 92. aastal. Köötav pind on natukene üle 1100 ruutmeetri. Hoones oli varasemalt kaugküte, kuid soe vesi toodeti siis elektriboileritega. Oli loomulik ventilatsioon, puudus siis mehaaniline ventilatsioon, rääkimata siis sooja tagastusest ja hoone omas siis energiaklassi E ja oli siis üle 230 kilovatt-tunni ruutmeetri kohta aastas. 2010 on tehtud eelnev energiamärgis. Hoone varasem välja nägemine on siis nendel piltidel toodud. See on ebatüüpiline hoone oma kujult kui ka siis suuruselt iseenesest ja ta oli üsna keerukas ja väljakutseid omav tegelikult renoveerimisele. Nii, ja siis lähteülesanne või ülesanne meie ees, mis seisis, oli siis, et rekonstrueerida see hoone eeltoodetud fassaadipaneelidega ja selleks siis meie partner Focchi pakkus eeltoodetud fassaadipaneele, mis siis töötati RenoZEB projekti raames välja ja demoti siis kahes riigis reaalselt, see on siis Eestis ja Hispaanias. Meie koos Tallinna Tehnikaülikooliga püüdsime leida siis parima lahenduse just Eesti kliimat silmas pidades ja meie kõiki ehitusnorme ja nõudeid silmas pidades, siis ka need paneelid välja töötati, aga sellest räägiti teile juba varasemalt. Loomulikult pidime järgima energiatõhususe miinimumnõudeid. Lisaks sellele, et kasutati siin ka RenoZEB-i ehk siis Euroopa Liidu rahastust, oli omanikel soov ka kasutada KredExi rahastamist ja finantsvahendeid ja seetõttu peab see hoone siis vastama ka KredExi rahastamistingimustele kui KredExi poolt seatud energiatõhususe eesmärkidele. Eesmärk oli saavutada B-klass, et minna natukene samm edasi siiski sellest tüüpilisest meil Eestis levinud C-klassist renoveerimise puhul ja loomulikult tagada korralik sisekliima ja tagada ka sisekliima energiatõhususe seiramine enne ja pärast renoveerimist. Need seadmed on paigaldati enne renoveerimist ja on seal praegugi ja pidevalt toimub siis sisekliima siis mõõtmine, monitoorimine, samamoodi hoone energiatõhususe monitoorimine. Ja alaeesmärgid olid testida siis ja piloteerida just seda fassaadipaneelidega renoveerimist Eestis. Teatavasti enne seda oli tehtud ainult üks Tallinna Tehnikaülikooli ühiselamu renoveerimine, siis Võrus proovisime teha seda siis teistkordselt, et nüüd iseenesest on KredExil ka olemas väga korralik taotlusvoor teha sellise renoveerimise jaoks, kus siis on juba 10 Eesti hooneid osalemas, aga huvitav on siis vaadata teist lahendust ka. Tagada loomulikult sisekliima teine klass, mis on meie nõue, paigaldada hoonele soojustakastusega ventilatsioon, viia soe tarbevesi kaugkütte baasile elektriboilerite lahenduselt ja loomulikult renoveerida siis ka vesikanal ja muud tehnosüsteemid, mis on kõik ühisomandis. Ja lisada siis ka päikesejaam taastuvenergia tootmiseks, et saavutada see energiatõhususe klass, mis on. selleks, et korralikult hoonega alustada ja teatavasti teha selline eelrenoveerimine või siis eeltoodetud fassaadipaneelidega renoveerimine vajab tegelikult väga selgelt hoonemudelit ja siis tellisimegi 3D mudeli. Ja see 3D mudel oli siis aluseks nii Eesti projekteerijatele kui ka varasemate nägite erinevatele simulatsiooni tarkvaradele ja modelleerimistarkvaradele, mida teile esitleti. Paigaldati sisekliima seiramise seadmed Enlife'i poolt. Tehniline projekt koostati OÜ Thermobilt poolt, nagu ma ütlesin, siis selle 3D mudeli alusel, pluss olid olemas muidugi varasemad joonised. Pean ütlema, et need ei läinud kokku ja seetõttu on alati raskusi reaalselt olemasoleva hoonega, et need vanad joonised ei pruugi minna kokku tegelikult reaalse situatsiooniga. See tähendab seda tegelikult, et see üle pildistamine või siis skaneerimine tegelikult on väga vajalik, eriti kui just teha sellise renoveerimise puhul just. Koostati energiasimulatsioon, saavutati energiaklassi XP ja 124 kW ruutmeetri peale aastas ja see siis ongi nüüd see eesmärk, kuhu me siis ka reaalselt tahame hiljem ekspluatatsioonis ka jõuda. Tehti taotlus ka KredExile, sealt saadi positiivne vastus, nii et rahastamises kasutati nüüd 3 või 4 siis rahastamisallikateks. Üks oli RenoZEB-i projekt, teine oli siis KredExi vahendid, 3. oli siis pangalaen ja loomulikult elanike enda korjatud raha. Ehk siis 4 sellist finantslahendust või finantsvõimalust allikat kasutati siis selle hoone renoveerimisel. Tehniline konsultatsioon oli siis TREA poolt ja vastavalt siis seadusele ja vajadusele tegelikkusele palgati siis ka omaniku järelevalve. Ehituse viis läbi ASMO ehitustööd tegelikult on, sellised vaegtööd on veel praegu tegemisel, iseenesest tegelikult on ehitus lõpetatud, aga seal praegu tegeldakse selliste nipet-näpet lõpetamisega. Ja omaniku järelevalve siis pakkus Kuldar Käsper. Nüüd projekteerimine vaade oli selline, see on projekteerija vaade, milline see hoone peaks välja nägema. Siis, nagu te näete, need tumedamad laigud tegelikult on päikesepaneelid ja päikesepaneelid on siis pandud nii seintele kui ka tegelikult katusele, et saavutada siis rohkem taastuvenergia tootmist, kuna need olid kõige sobivamad päikesepaneelide asukohad, aga iseenesest hoone väljanägemine oli joonisel või siis mudelis selline. Nüüd lisaks veel sisekliima energiatõhususe mõõtmine, nagu ma mainisin, paigaldati siis mõõturid Enlife'i abiga, kus mõõdetakse temperatuuri, õhuniiskust, CO2 ja lisaks veel mõnes kohas välisseina sisekülje temperatuuri ja välistemperatuuri ka, et saada siis hea ülevaade sellest hoonest nii enne kui pärast. Ja igas korteris on siis temperatuuri, õhuniiskuse, CO2 andurid ja siis 6 punkti on välisseina sisekülje temperatuuri mõõtmiseks just ja välistemperatuuri mõõtmisi on toimetatakse ka 3 kohas. Ja loomulikult mõõdetakse siis ka hoone üldist või siis summeeritud energiatarbimist, ehk siis soojusenergia, mis tuleb kaugküttest, seda läbi 3 soojusvahetit on paigaldatud siis elektrienergiat, PV ja siis päikesejaama toodangut loomulikult mõõdetakse ka. Nii, nüüd ma võtan siin ventilatsiooni paigaldamisel, ventilatsioon paigaldatud läbi on viidud ka siis ventilatsiooni parameetrite mõõdistamised, need vastasid kõik normidele ilusasti. Nüüd ma räägin juba tulemustest ja huvitav, miks ta mul ei taha liikuda. Siin on siis näidatud ära, mis punktides, et igas korteris erinevates tubades siis või erinevates ruumides vaadati siis ventilatsiooni ja siin on siis tulemused rekonstrueeritud.
Excuse me, I'm sorry to interrupt. Martin, sorry, yes. We might have some problems of echo at your side, so the translation is not perfectly. Perhaps if you could make your mic closer to your
okay, is it now better? Is it now better?
Yes, a bit better. So let's try to progress that way. Thank you very much. I'm sorry to interrupt.
Oh, no problem. Yes. Yeah, I didn't see these information. So ja, et tulemuseks oli siis see, et maja sai korralikult renoveeritud, osaliselt fassaadipaneelidega, mitte täielikult. Ja renoveerimine siis on nüüd kohe lõppemas, täielik renoveerimine. Nagu ma mainisin, siis 124 kilovatt-tundi on arvutuslik ketta. Vaatame, mis on KEK ehk siis kallutatud energiakasutus pärast seda, kui me oleme 1 aasta siis, eks ju, ekspluatatsioonis hoidnud seda või hoone on toiminud, et eks siis on näha seda. Paigaldati soojustagastusega ventilatsioon, uus soojusõlm, loomulikult 3 kontuuriga, eraldi kontuur ja soojusvaheti kütteks, eraldi sooja tarbeveeks ja eraldi siis ventilatsiooni eelsoojuseks. Soojustasega ventilatsiooni oli 2 seadet ja umbes 35 kilovatine siis päikesejaam asub siis 3 kohas, katusel ja 2 seinal. Ja loomulikult kõik tehnosüsteemid said vahetatud, ehk siis see lähteülesanne, mis sai püstitatud, sai täielikult täidetud renoveerimisega. Nüüd jääb üle meil lihtsalt vaadata, kuidas siis maja käitub tulemusel. Nii, ma ei saa kuidagi vahetada slaidi praegu. So it's too slow or okei. Nii, et selline see maja on nüüd õhtupäikeses näeb välja. Et siin on mul nüüd toodud järjestikku mõned pildid sellest hoonest ja ma proovin teile siis näidata, milline see hoone siis välja näeb. Nii. Nii, nüüd on siis mõned pildid sellest hoonest, mis on siis, kuidas see hoone välja näeb. Aga nagu ma mainisin, siis 16. juulil on võimalik seda Võrus kõigil näha, et kes soovib, see saab tulla Võrru vaadata ja rääkida ehitaja ja omanikega, kuidas need asjad on siis välja kukkunud. Nii, siin on nüüd pilt enne ja pärast lahendusest. Ja sellega ma tõmban praegu otsa kokku. Mainin veel kord ära, et 16. juuli kell 11–12 põhimõtteliselt on võimalik seda maja silmast silma näha ja katsuda. Aitäh teile kuulamast.
Okay, thank you very much for that. I think we are ahead of our time. So if you have any questions, please just put in the chat box. So we will wait for a few minutes for questions. Otherwise, we move on and close the meeting. But let's just wait a little bit.
I have. It's Martin here. I have a question to Anne.
Sure, please go on.
Anne, how you see is that Hyperterm software will be available after project end and will be free to use continuously?
Can you hear me? Yes. Yeah. Okay. Cype term, you can ask for a free trial. I do think the free trial is 1 month. Okay, after that you will have to purchase the software. Maybe if there's people interested in this call, we can do a list and have these licenses submitted.
Thanks.
Thank you very much. Okay. So if we have no more questions, I would like to thank you everyone for coming, all the speakers as well. Thank you very much. This is the RenoZEB training day. Once again, as Martin invited you, so we will have a site visit on Friday in Vuro. So please, if you can go join us in the site visit, and thank you again for attending this meeting, and hope to see you on Friday. Not me, but Martin, yeah. So see you soon.